As we continue our discussion of stoichiometry, the next thing to talk about will be the limiting reactant concept. So if you go back to the very first problem we did in our problem set, and we used this picture, it had given us a certain amount of each reactant to play with to make products. And we learned that we have to take those in the order that is designated by the balanced chemical equation. So we took 2 sulfurs, and then we took 3 O2 molecules. We combined those together, and we quickly made 2 SO3s. So we went through once, and we made 2 SO3s. We went through again, we made 2 SO3s. But when we tried to go again, we found that we did not have enough of the O2, and we ended up with these 2 sulfur atoms left over as excess reactant. And the thing that limited how much product we could make was the O2, because it's the thing we ran out of first. Now we're going to take this exact same concept and do calculations with it. Let's look at one reaction and one question about that, and let's look at the 2 methods that are most commonly used to go at a limiting reactant problem. To recognize one, first of all, you're going to be given an equation. You may need to balance it yourself, but you will have the reaction equation. And then when you read the information given, you're going to be given information about both, or at least more than one, reactant, and asked about a product. And all the problems we've done up to now, simple stoichiometry problems, if you look back, you would have been given one piece of information about either a reactant or a product and asked to tell me how much of one other thing in the reaction would be involved. Whether I tell you about a reactant and I say, if you had this much reactant, how much product can you make? Or if I say, hey, if you're going to make this much product, how much reactant did you need? You're still doing the exact same logic of go to moles, use the mole ratio between those two to get to moles of the new thing you were asked about, and then go to whatever unit the problem actually asked for. Whether it was moles, you're done. If it's something else, you need to do some more work. So one of the methods for working this type of problem, my favorite actually, is exactly that logic. It says, take this one, go that reactant, and go to products and figure out how much you could make if you used all of this one. That assumes that's the limiting reactant, and you have excess of the other one. And then as a separate calculation string, you're going to say, okay, if this was the limiting reactant, and I used all of this, then how much product can I make? So you're going to have 2 answers. And if you think logically and you realize that the reactants have to combine together to make the products, then whichever one of these calculation strings predicts the lowest amount, well, that's the only possible right answer, because they have to come together to make product at a set ratio. And if you're saying there's only enough, say, silver nitrate to make, I'm just going to throw a number out there for a second, 2 moles of silver, even if there was enough copper in there to make 8 moles of silver, you're never going to make more than 2 moles because you're going to run out of silver nitrate at the time you do. All right, so let's take these actual numbers and let's look at the 2 different methods. So the method I explained to you is actually method 2 in this description. So let's jump down here real quick because that's the one I actually do the most. And I think it's the easiest to understand. It's the easiest math, I think, because it's the same math you've been doing without any big logic decisions. So for this one, you're going to take each of the quantities of reactant, like we said before. You're going to use the mole ratio between that reactant from the balanced chemical equation. You're going to grab that. You're going to say, and it says from the balanced chemical equation, it says for every 2 moles of silver nitrate that go in, 2 moles of silver come out. So that's the mole ratio we're using. 2 moles of silver nitrate in, 2 moles of silver out. So if you do that math, that predicts 3 moles of silver. And you need to understand this is an if-then statement. Okay? So if all of the 3 moles of silver nitrate present reacts, then 3 moles of silver could be formed in the reaction. So it is very much an if-then statement. So once you have that if-then statement, you're then going to look at the other. And it is an or, guys, it is not an and. So now you're going to say if all of the 2 moles of copper nitrate present could react, then, and that's where we end up, we go back to the balanced chemical equation, and there's a 1 in front of copper, so it says for every 1 mole of copper that goes in, 2 moles of silver comes out. You do that math, you're going to get 4 moles of silver could be. So it's a if all of the 2 moles of copper reacts, then 4 moles of silver could be formed. And this is where you have to respect that they have to react together. You have got silver nitrate coming together with copper. You've got them coming together by this balanced equation. They're coming together. 1 copper gets together with 2 silver nitrates, and they make 1 of those and 2 of those. And again, you reach into the bucket. You grab 1 copper, you grab 2 silver nitrates, you rearrange the atoms, you make 1 copper 2 nitrate and 1 silver atom. And you do that over and over and over. But all of a sudden, you go to reach in the bucket, and you will not have enough of one of them to do that 1-to-2 ratio and keep going. So the reaction will stop. And what you just told me was that there's enough silver nitrate to make 3 moles of silver using the balanced chemical equation as it's written. And there's enough copper that if you had enough silver nitrate, you can make 4 moles of silver. But if they're reacting together, do you understand that if there's only enough silver nitrate to make 3 moles of silver, you're never going to be able to make more? That means you're going to keep grabbing 1 copper, 2 silver nitrate, 1 copper, 2 silver. You keep doing that over and over and over. And then when you go to reach again, you're not going to have any more silver nitrate, even though there is copper left over. So what that tells you, when you look at it, what that's going to tell you is that the smaller possible answer you're going to get from those 2 calculations is the right answer. And we call that the theoretical yield because it's the mass yield you should get. The limiting reactant is the one that produces that smaller answer. So the reactant that gave you predicted the smaller amount of product is the limiting reactant. And the larger number is basically just fiction. It's not possible. You're never going to make that much because there's not enough of the other reactant present to do so. So the right answer is the 3 moles of silver from the silver nitrate. You cannot make, this is a no. This is a nope, never going to happen because you don't have enough silver nitrate present to make more than 3 moles. So that means the silver nitrate is your limiting reactant. And the 3 moles, even though we'd normally do theoretical yield in grams, and we could do that extra step to get to grams, but you can still say that's your theoretical yield of silver. The copper is the excess reactant. And we could actually go through the trouble and we could start with our limiting reactant. And not only can we predict how much product we should make, we could calculate how much of the other reactant we're going to use in the process of using all of our limiting reactant and subtract that from how much was actually put in the flask to tell us how much will be left over when the reaction stops. Okay, so that's method 2. That is definitely the one that I suggest people use because I'll show you more in a minute, but really it's the same kind of math. You do this math when you're doing the simple stoichiometry problems. You go to moles, you relate in moles, you go to the new unit they want, starting with one thing, ask about another. So this way of working the problem is that you do that once for one reactant quantity you're given and go to the product it asks about. Then you do the same process again using the other reactant going to product, and you simply compare the two answers, and whichever answer is lower is the right answer. Most people find that method easier. The second method involves comparing the two reactants to each other. So we would respect that from the balanced chemical equation, we have this relationship. For every 1 copper, you need 2 silver nitrates. So pick one of the reactants, doesn't matter which one. We're going to pick the 3 moles of silver nitrate quantity, and we're asking the question, how much copper will be needed to react with all of those 3 moles of silver nitrate? So we use that same mole ratio from the balanced chemical equation that relates those two together, and you calculate that 1.5 moles of copper will be needed to use all of the silver nitrate present. Well, we have 2 moles of copper. So this is where you have to make the logic decision. You have to think about it for a second. You say, I need 1.5 moles. I have 2. If I have more than I need to use all the silver nitrate, then that means the silver nitrate is what will be running out first, and I will have copper left over. So that's how you're determining who the limiting reactant is. So if it's limited by the amount of silver nitrate present, silver nitrate is the limiting reactant. That's what we call it. And then this is what you would use to now do the second string of calculations, which is start with silver nitrate now that you know that's the limiting reactant, and compare that to product. And now you can go confidently knowing that starting with silver nitrate is the right one to do to get the right answer of how much silver could be formed as your product. So with this one, compare the two reactants, figure out which one will be the limiting reactant based on how much you need versus how much you have. Once you make that decision, you use the limiting reactant to then calculate how much product could be made. So again, it is still 2 calculation strings, but because there's that logic decision that has to happen in the middle, most people prefer this one because the only logic you have to get is that this is it's an either or. Either the silver nitrate's the limiting reactant or the copper is. And for each one, you do the, if I could use all the silver nitrate, I could make that much product. If I could use all the copper, I could make that much product. And the only answer that can be right is the lower one. So I always tell students to please just use whichever method works for you. Whichever one of those methods like made the most sense first time you heard it, that's the one you should probably stick with. All right, so once we figure out who the limiting reactant is and we calculate what the theoretical yield is, our next question, and obviously a really big question for chemists, is how did we do? What kind of efficiency did we have in our reaction? How much did we get compared to how much we were supposed to? Well, that's called percent yield. And with percent yield, not percent error, be careful. You've been doing percent error in lab. Percent yield is going to be actual over theoretical times 100. So it's how right you are. Percent error is how wrong you are. So be careful. Percent error is the difference between the actual and theoretical in the numerator over the theoretical. Percent yield is just put the actual, the part, over the whole, the theoretical, times 100. So we will add that step. So say what student went into the lab and they ran the reaction we were just discussing and they managed to isolate and collect 2.85 moles of silver. Well, if they collected 2.85 moles of silver and they were supposed to get 3, then 3 is the theoretical, 2.85 is the actual. Actual is also called experimental because obviously it's you running an experiment to collect that data. The actual over theoretical times 100 will give you the yield. And 95%, yeah, that's real good. All right, let's do this example problem. And one reason I want to work this example problem is I want you to notice the way it's worded because I think this might be one of the most tricky ways, but yet very common way these problems are presented. It says a student reacted 1 gram of silver nitrate with 1 gram of magnesium chloride by the reaction below. And be prepared to need to balance this yourself, but in this case, it is balanced for you. It says, number 1, what's the limiting reactant? Number 2, what's the theoretical yield in grams of the solid silver chloride product? And 3, if a student was able to collect 0.655 grams of solid silver chloride product, what was the student's percent yield? So it's the fact that this asks what's the limiting reactant before it says what's the theoretical yield that makes students often think they have to use method 1 and determine the limiting reactant first and then do the second calculation, but that's not true. If you do method 2, you're going to be calculating both of them at the same time. So I'm going to use method 2 to go about this. Well, method 2, that's where you take each of the reactants and you go to products. So I'm going to take the silver nitrate and I'm going to calculate how much silver chloride could be made if I use all the silver nitrate. And then as the second calculation, I'm going to take the magnesium chloride quantity and I'm going to calculate how much silver chloride could be made based on using all the magnesium chloride. So you will use pink for the silver nitrate calculation to keep it straight. It says that I had 1 gram of silver nitrate, so 1.00 grams of AgNO3. We're going to need to go to moles. We're going to need related moles. And since it did in number 2 ask for the theoretical yield in grams, we're going to go ahead and go from moles of the new stuff or product to grams of. So we're going to go from grams of AgNO3 per mole of AgNO3. We're going to go from moles of AgNO3 to moles of the product it asked about, which is AgCl. And then you're going to go from mole AgCl to grams AgCl. Okay, if we run to the periodic table and add that up for the silver nitrate, it's 169.88. If you look at the balanced chemical equation, there's a 2 in front of silver nitrate, so I'll put that right there. And there is a 2 in front of silver chloride, so I'll put that right there. Run to the periodic table again. Oh my. So this was periodic table. This is going to be from the balanced chemical equation. And grams to moles again, that is periodic table again. So add up 1 silver and 1 chlorine, and you'll find that to be 143.32. And if you plug and chug through there, you're going to get that there's 0.844 grams of silver chloride possible. So again, this is if the 1 gram of silver nitrate is all used up, and that ends up being the limiting reactant, then you will make 0.844 grams of silver chloride. So now you need to do the other string, the other possibility. 1.00 grams of magnesium chloride. So that's your other reactant. MgCl2. You're going to do the same idea of the 3-step calculation. So we'll go from grams of MgCl2 to moles of MgCl2. From moles of MgCl2 to moles of product. And again, that's going to be AgCl. And this last step is obviously going to look exactly the same. It's going to be a 1 in front of MgCl2 and it will be the same 2 in front of AgCl. If you use the periodic table to add up the formula weight of MgCl2, you're going to get 95.21. If you plug and chug through that, then you're going to find the answer would be 3.01 grams of AgCl. Well, that sounds better. It sounds better that we would be able to make 3 grams of silver chloride instead of just 0.844. Well, if these were two completely independent things, sure, but remember, this is an or. Either the silver nitrate is going to run out first and limit how much product you can make, or the magnesium chloride is going to run out first and limit how much product you can make. It can't be both. So the reality is that the 3.01 grams of silver chloride is never going to happen when you only have enough of the silver nitrate to make 0.844 grams. So that is the right answer. And is your theoretical yield. Meaning the thing you ran out of first was the silver nitrate, which is your limiting reactant. So now go back up to your problem, and number 1 says what's the limiting reactant, so you can say AgNO3, and it says what is the theoretical yield in grams, and you can say 0.844 grams of silver chloride. So you've answered both of those. So the last thing it says, if a student managed to make, and what's percent yield? So if a student managed to collect 0.655 grams of AgCl, and their theoretical you calculated was 0.844 grams of AgCl should be collected. Multiply that times 100 to make it percent, and you plug and chug through that math, and you will get 77.6%.